Hi, I'm Paco Nathan from O'Reilly Media, and we're here at JupyterCon. It's a pleasure to get to speak with Peter Wang, co-founder and CTO for Continuum Analytics, and really enjoyed your keynote today.
Thank you.
It was super inspirational for us.
Thank you.
The themes of communities, and definitely when you have an open source project, what does it take beyond just having the code committed there? What about the people and the interactions?
Right.
Speaking about Jupyter, one of the things I wanted to lead off with was what's been the most unexpected thing for you in terms of how Jupyter's popularity, how it's rolled out?
Well, I think one of the things that's really interesting is how watching people, the sense of empowerment that when they realize they can make things in the web. And I know you're like a long time internet technology enthusiast, let's say, and we've always thought of the internet and the web as being this incredibly democratic medium. But in the last maybe 15 years or so, Eternal September was a while ago, but it's really turned into more of a broadcast medium, right? People are used to consuming things, especially now more with smartphones, and so people you forget what you give up when all you do is consume media, consume. Right. And what I've seen with Jupyter is that people once again get that feeling of, making something in the browser is something I can do. And I being a geologist, I being a social scientist, right? I being anybody, I can actually, not only can I play with my data, which is awesome, right? That's awesome, but I'm actually creating a thing. I'm creating an artifact. I'm creating a thing that I can share with other people. And that very human act of creation and then of sharing is something that we always, we've known. The internet was supposed to do this, right? It was supposed to just have this, and yet it's been slowly taken away from us, just removed from the expectation. Yeah. And I think one of the really cool things, and probably one of the most promising things about Jupyter, is that it restores that the democratic aspect of creation in the online medium. And so for me, it's that's probably one of the most unexpected things, because I can write websites. It's not unexpected to me to be able to write a website, but it's unexpected to see how empowering it is for people who are not web developers, right, to be able to go and build something interactive and neat online.
Talking about open source, one of the things that really struck me from the keynote was just how crucial some of these projects are at the very core of infrastructure. You gave an example about email and spam and also security. We're talking about OpenSSL and Heartbleed. In your opinion, one of the things that came to mind there was, in your opinion, is there a kind of overhang of liability for public infrastructure that depends on crucial resources in open source for those projects to be supported more formally?
Is there an overhang of liability?
Well, like a case in point would be with OpenSSH. A lot of people depend on that.
Right.
So do we need to do more of a perspective of how much we're depending on open source and really commit more public funding to it or more enterprise funding to it?
Yeah, so maybe the way to put it, my thought on it is that software does this really weird thing that's counterintuitive to us, which is that it really has the relationship of capital expenditure versus operational expenditure are really different with software.
Okay.
Most things that people have an intuition about in physical life, let's say, if you want to build a house, if you want to go and build a ship, if you want to do whatever, there's an effort that we understand must be undertaken, right? And that effort is what we call capital expenditure, right? You have to go and draw up the plans, get the concrete, pour the foundation, build all the stuff, wire it. But with software, that capital expenditure usually it's actually the concentrated effort of a relatively small number of people, and most of the software long tail kind of cost is the maintenance cost, and that's sort of the operational expenditure, right? But most of the operational expenditure you get with software, because software doesn't really erode, so to speak, it sort of falls out of sync with the world around it, with the digital world around it, but it doesn't really you can still go and play Minesweeper and Solitaire, right, from the mid-90s. Exactly. You can still go and run DOS games, right? They never stopped working.
Right.
You just can't Instagram your screen capture from King's Quest, right? But But the real world is not like that, right? If you don't maintain a building, a hurricane's going to blow it down, right? Or some electrical short because of a mouse is going to burn the thing down. And so with software, almost all operational expenditure is insurance. It's technical insurance. It's risk mitigation. And it's the idea that if we pay the maintenance now, it's cheaper than when it does fall over later. So in terms of liability then, or kind of the debt, so to speak, the overhang, right? The debt is simply just pending insurance premiums, right? And if you never pay the insurance down, at some point when the stuff goes down, when it goes south, well, you just go and pay the capital expenditure to rebuild it again, right? And so I think it's a very different kind of thing than, like, the upkeep for software is not actually upkeep because the software just stays up. It's really keeping the ground clear so when you do have to rebuild, it's cheaper to rebuild. So it's a different. This is a really weird, geeky economics argument, I guess.
This is a great.
But that's kind of how I think about it. Is like, and actually, this, like, I wish they taught this. I wish they would teach this in every single CS course, right? Because you have to understand, software's power is that the distribution cost goes to zero, the reproduction cost goes to zero. It doesn't have to be maintained because once the bits are organized, they're organized, right? And entropy is actually relative to all the environment around it. And so, with that in mind, the way you have to manage software is different, and the way you think about the cost of managing software is different. So, but to the broader point of your question, I think that the world at large does need to become more cognizant of how much it depends on these open source efforts from just a few contributors. And I'm not sure. Again, I guess it's a question for the community, right? How best to go about that? I don't have any cute answers there, unfortunately.
No, this is great. This is getting the most important matters up front, so that people can join in. It opens the door also for as a computer science major, you should probably have insurance people talking with you, or maybe insurance companies should be taking a look at how they can help out with popular open source projects, because that does seem to fit more the model. Yeah,
I think that you could actually go through. The problem is that I think the mechanism for insurance also then has to tie into liability. So because companies, I don't think it's quite so obvious how companies get held liable for faults and failures in software. See, I mean, even in cybersecurity, right? When some company, because they goofed something up, they leak 100 million records of private user data. I feel like people don't take the insurance aspect of it seriously enough because the costs of having these goofs is so small yet, right? Once the lawsuits, if there ever is some serious punitive stuff coming this way, then they're going to want to buy insurance. Once they want to buy insurance, and the insurers are going to want to actually come and assess what is your compliance. Like, not just compliance paperwork-wise, there's already an infinite amount of compliance paperwork for any kind of large company. But, like, actually evaluating risk, like at an actuarial level, right? What version of what software, what packages, what libraries. Right now, very few companies even think about this. And ours is one of the ones that can actually do some actual technical assessment on the open source data science kind of pieces, and even then, it's not perfect. But
I can imagine you have a excellent vantage point, a real bird's eye view of exactly where those dependencies are and what some of the interactions would be because of what you're seeing at scale.
Yeah, we sort of have a lot of interesting ideas for how to tell businesses. For them, it's not about loss aversion, like, oh, my data got breached, or this model stopped working, but it's more about helping them understand the cost of future change. So let's say you are CTO for some big insurance company, or we're in New York, so some big hedge fund or something. You got a pile of data scientists, they build some models and they work, or they build some stuff, and you're like, oh, this is really good, let's put it in production. As a CTO or someone who manages all this, you want to understand, what is my likely cost of maintenance for this to keep it relevant and accurate moving forward. And if you have no visibility into the health of the projects you're using, you have no possible way of answering that question. You're sort of like, well, I'm going to maintain my staffing levels here and just pray, right? That's the best I can do. That's the best anyone can do. What we're hoping to do is actually work with the community and also do some legwork on our own to actually start giving people an ability to have visibility into, what, most of your models that you've gotten to production, they're using these very well-maintained, healthy projects. But you got a couple that are relying on some old stuff. So you might want to think about, at some point, either rewriting those things or building a different dependency in or something, right? That kind of actual software having that visibility into your upstream risk is not something that I don't think anyone really offers that.
No,
So,
any data services in the works for this?
So data services are interesting. We've thought about what would be an appropriate thing to do to make a play kind of in the data space. We've not really done any efforts there. I think there's a lot of people who are trying to do good work in community data sources and these kinds of things. There's a company in Austin called Data.World.
All right.
Years ago, there's InfoChimps, right, that wanted to be a data marketplace. And so I think those things will continue. There's large public data sets on the various cloud vendors. I do think that as deep learning and AI evolve, they're going to basically drive some kind of community dynamic where we'll have some standard data sets in subfields of data science like networks or GIS. They're sort of like standard data sets people know about. I think in the broader machine learning space, we're going to have a similar kind of thing. There's going to be well-known data sets that people will start using. But in terms of actually providing commercial data services, I actually think that's an incredibly hard thing to do in general. Data connectors is probably better. Yeah.
Now, as far as Jupyter, what are some areas where Continuum is using Jupyter?
Well, so we've actually used Jupyter from the very beginning. So Continuum started in 2012. Jupyter notebooks the web notebooks were released in 2011. And then in the fall of 2012, we released an actual cloud-hosted online notebook service called Wakari. And we realized very quickly that actually, as a small startup, we do not have the funds to keep this a popular web service running. We were just paying a lot of money to Amazon every month. And so the thing we realized is people want to run this stuff on-prem. So we built an on-premises enterprise notebook product, and we're still selling that, and that's still very popular. We've now evolved that to be a much broader enterprise deployment capability, as well as notebooks and all these other things, and package management. So it's part of our overall enterprise offering. And we've also stepped up to help on the Jupyter Lab project. And so some of the core Jupyter Lab developers are Continuum developers. And we've folded Jupyter Lab into the core of our next version of our enterprise platform. So we absolutely use in the core. Many of the devs at Continuum also contribute to the open source Jupyter ecosystem. So things like some of the presentation views and MB Convert and MB Viewer. There's a bunch of different places where our devs have plugged in on things. So yeah, we definitely have a lot of interaction with the Jupyter folks.
Oh, excellent. From that perspective then, are there gaps that you could point to where people should try to focus? Anything in Jupyter that you would say that, likely suspects, I guess?
Yeah. Well, I think what's going to happen with Jupyter is that people are going to start building really interesting application dashboard, whatever kind of things. They're going to build sort of targeted UIs for certain kinds of data transformation or data analysis. So those targeted things, that's the kind of thing that's perfect for a platform like Jupyter, right? Because who better to build a UI for some kind of weather prediction or some kind of disease model than the actual scientists doing the modeling, right? So that's, I think, going to get taken care of. The hard part is just one layer down at the infrastructure layer, building broader tools. So building a really solid open source Jupyter Lab native data wrangling tool, right? That's the sort of thing that's incredibly hard work. It has 1,000 little doodads and knobs and switches and bells and whistles, and every single user thinks their feature request is the most important, right? And you're not building a data wrangling tool just for genomics or just for cyber threat modeling. You're trying to build this general thing is really hard, and that's where it takes a community effort to all rally together to say, no, we're not going to each build our own slightly crappy 65% good data wrangling thing. We're going to build one. We're going to just do this one. And cohering an effort like that in the open source is extremely difficult. So I think it's things like that, right? Maybe some nice SQL interfaces and SQL data visualization kind of things. I guess that's also still tied to the data wrangling bits. So those kinds of things are, I think, where the ecosystem needs to go next.
Now, one thing about Jupyter is that it works great if your laptop has the compute power and the memory for what you need to run. I've run into cases lately where I don't have enough GPUs on my my laptop there for it, for the thing that I really want to see.
Or enough is one, right?
Yeah. Well, I was curious about that. I know that Continuum has also been working with parallelization of workloads. Does that intersect some with your work with Jupyter to be able to make processing backends much more reasonable?
Yes. So there's two aspects of that. One aspect is the parallelization of compute, right? Okay. As you say, and that the work we do there is actually kind of at a lower level. It has not much to do with Jupyter really. Right. Jupyter's a nice environment to do it in because you have this nicer UIs you can build, right? Trying to offer people good usability at just a standard like VT100 terminal is it's like not great. So the Jupyter gives much nicer things. So if you look at Dask and you look at doing parallel jobs in Dask, you have a nice dashboard you can look at. And so I think we'll have better things like that servicing in Jupyter. The Spark ecosystem already has things like Zeppelin and whatnot that gives them that nicer interface to their parallel compute. But the other thing that we work on is helping to move workloads from a local machine to cloud or to server workloads. And so we've built, the stuff we've built around Conda packaging is actually, it's kind of a geeky point, but it's actually like really important to this, right? Because if you use packages X, Y, and Z, and the server or the cloud thing you want to move to doesn't have those packages, you can't move your work, right? You're stuck on your local machine. And so with Conda packages, we provide at least a basic infrastructure to be able to move your work across. What we've done next is created actually a new project called, oddly enough, it's called Anaconda Project. It's a project called Anaconda Project. Okay. But it essentially is taking that Conda environment concept in the package encapsulation to the next level. So it's like a lightweight Docker for data science, but there's no machine virtualization.
Right.
There's no like, you must use this little Ubuntu image or anything like that. It actually is native on all the platforms. And it basically just lets you very easily describe your data science project and have that then move from your local machine to a remote machine or to the cloud. And we hope that the Anaconda project effort, coupled with Jupyter Lab, will really start creating this portable encapsulated data science kind of capability. Oh. And so, that's one of the things that we're very excited about.
Oh, fantastic. That view of packaging and encapsulation, it strikes me that would fit really well with what's emerging now in terms of more of the kind of serverless architectures.
Yep.
So, we've seen this trend to have more lightweight virtualization with hypervisor and LXC and Docker, but even going beyond that now into more serverless. So it does seem like Anaconda Project and what's going on with Python would map into the world of like Cloud Function and Lambda and the rest.
Yes, so there's definitely use cases there that dovetail very nicely into some of the technology that we've built. I think it basically increases the number of workloads you can do in a serverless or present in a serverless kind of facility. At the end of the day, there's no free lunch, right? So if the work you're doing requires the generation or the management of persistent state, someone's got to manage the state, right? And so what we're trying to do with things like Anaconda Project and to some extent Conda environments is to make the management or just create some structure, some interface where you can declaratively talk about what your dependencies look like for the runtime, what your dependencies look like from an authentication and data access perspective. Have a declarative way, essentially, of talking about what is the necessary conditions for your code to just run, right? And then once you have that in a declarative form, a lot of infrastructure can be built out that understands that declaration and provisions things for you, manages them for you, can understand a reasonable correctness of the runtime. Because that's where these things tend to fall over, is if you can't provide a way for the human to talk about what is the correct operation of what I'm trying to do, then there's no possibility for engineers to go and build infrastructure that manages it for you, right? They can just sort of fire and hope and pray, but they certainly cannot build any kind of guarantees around the service. So,
in terms of dependencies too, people think about package dependency, what library, what point release, but it's a much larger problem. You were talking about data, I imagine some access, grants, permissions, things like that. What's kind of the breadth of that then?
Well, it it goes, well, man, it's turtles. It's angry turtles all the way down.
All the way,
there's a great quote. I forget where I saw it. It must have been Hacker News thread. Someone made the point of like, for 40 years now, we have tried so hard to make software and programming independent of data, to make code independent of data,
right.
And yet all code is meaningless without data. And so this is not Hacker News comment. It was some famous computer scientist who said this, and I'm very embarrassed I've forgotten.
No.
But anyway, the point is that the merger of code plus data is nothing new, and in fact, it's kind of back to the future, kind of, right? Like this is what it's always been, really, and it's just been the conceit of software developers as a community, as a profession, maybe, that we just think about code, right? And all of our code is data independent code. But actually, we're coming back now to where enterprise applications at large and small scale, macro scale and micro scale, everything we're building, all the code is really there to serve business functions that require some level of data input. So managing the data provenance and data governance is nothing new, right? And we should never have really believed we could get along for as long as we did without thinking about that as a first-class concern. So I think that's really at a high level what we're coming back to. Okay. So all the problems, they're the same ones we've always had. We just can't silo them anymore between, well, this is the DBA's problem, here's your SQL query and your credentials, and you guys are software developers, so just write this like JDBC bit, right? It's actually all going to come back together.
Fantastic. One last thing I'll wrap up with. Any good advice that you have that you can share for people who are starting out open source projects? They see a need, but they're just even beginning to learn how to build a community. Mm-hmm. How, from your perspective, having a business based on open source, but what's really important there? What really matters to learn to try to start that?
So building an open source code. So if you want to build an open source project, there's two parts that you have to get right. One is the code part, and one is the people part. To get the code bit right, I would say that if you're going to start an open source project, do it for the right reasons. Right. Don't do it for the GitHub stars. Right. Don't do it for the fame. Right. Don't do it for the glory, because there's not much, none of those things, right? A lot more blood, sweat, and tears than those things. But actually, the way that I've seen open source projects really become successful, whether they're like weekend hacks, like Fernando's little IPython project, whether it's like Wes McKinney on Pandas, just coding hard for years, the ones that have been really successful are where the person who made the code is doing it to scratch their own itch and to scratch it really hard, right? So on the code side, be guided by your own sort of technical desire and to try to solve a problem right? And really, if you're the founder of a project, you have to hold the line on that vision, right? So own the technical vision, and that's one part of it. The other part of it, though, is the people part. So successful open source projects have to have both. And the people part is that you have to be, in addition to holding the technical vision, you have to essentially be able to conduct yourself in such a fashion that you maintain integrity and credibility. Right. And the Python community is absolutely fantastic and amazing because as a technical community, it's managed to grow and scale and still hold that line. Other communities have unfortunately fallen by the side. They don't have that characteristic. And so I think that's the short and cute answer, is that actually integrity matters, credibility matters, and as the leader of an open source project, it's like the leader, it's basic leadership, I guess. There's nothing different. If you're going to lead an organization, a company, a platoon, you have to have credibility, and that credibility comes through your openness and kind of your integrity, right? Commitment to the project, commitment to the vision. Both of those things are absolutely critical in order to build a successful open source project.
Wonderful. Thank you very much, Peter.
Thank you, Paco. It's a pleasure.
Wonderful.